Hello, everyone. Thank you for joining to our dive into 5G automated multi-cloud service delivery session. I'm Moshe Lavi, and I'm the Director of Product Management, leading the automation and orchestration product in TechBU, and with me, Akshata.
I'm Akshata Satyanarayan, leading the engineering team for Telco Cloud Automation as part of TechBU.
Thank you, Akshata. Okay, so in today's session, we will present the evolution that we are making into 5G and the requirement behind these use cases of 5G. Obviously, that these use cases are going aligned in the VMware end-to-end strategy to support any device, any application, and any cloud. The session today will mostly be focused on the telco cloud that you see on the bottom. It will touch a lot around the traditional application transitioning into cloud native application. And at the end of the day, it will serve the goal of supporting any device, as you can see in the top layer. Basically, 5G use cases are the engine around allowing the transition into a world of many devices and any application, and we will touch that during the session. In terms of the TechBU portfolio, so we are promoting the 4x3 metrics, which basically said that the TechBU serve portfolio that goes into any cloud, starting from the core, the edge, the RAN, and the private 5G. We are focusing in three different layers, starting from the TCI, which is the telco cloud infrastructure, serving the SDDC stack, including the storage, the networking, and the virtualization. Going forward into the automation layer, which basically allow us to reduce our operational expense by delivering automation that can create a repeated automation to allow and support the 5G use cases as we will touch during this session. And on top of that, we have a specific product line of operation TCO, Telco Cloud Operation, which allow us to serve over-the-top value on top of the infrastructure and the automation, mainly around the optimization and the assurance functionality. Going into the agenda of this specific session, the topic of the session is dive into 5G automated multi-cloud service delivery. And the main pillars that I'm going to present in this session along with Akshata is how 5G disrupting the cloud industry, what are the main requirements and the approach into the 5G over multi-cloud, and how automation assists us to overcome these barriers and basically promote ourselves into 5G without increasing our operational expense. I will start very fast by describing the key requirement around 5G. So with us, you can see on the slide a quick view of a traditional 4G network, and I will speak about what are the key requirements in order to take this networking to the 5G world. So obviously, when we are talking about 5G, we are mainly talking around how we take the application closer to the customer, closest to the edge, by deploying a lot of new run sites. These run sites during the 5G time will be mostly virtualized sites. And with that, there is the requirement from VMware in order to bring the virtualization into the edge and allow the customers to deploy lots of new run sites at the edge in a virtualized approach. This virtualized approach takes us into a new form factor of virtualization. We are not longer talking about the VM type of form factor. The requirement for the edge is mainly to deploy a Kubernetes stack, which is more agile and scalable. And for that, we see the requirement of a flexibility IaaS CaaS platform, running mainly to the edge and then taking them into the core. With the new type of services comes new types of application, and obviously since the technology is changing and the form factor of the application is changing, we need to take all this application and to onboard them into the different infrastructure that we are delivering into the 5G use cases. So with that comes a requirement to integrate all the different vendors that assemble the 5G network and to onboard them into a meaningful template of an application, a CNF, a VNF, and at the end, it's to network service if we are talking about an AGNF function. On top of that, there is obviously the requirement to keep the security, and for that we need to deliver end-to-end isolation, including tenants, and speaking specifically about containers, how we control the labels, and how we make sure that we keep the same multi-tenancy with namespaces in a similar way to what we used to have with the tenants and organization during the VCD or the VIO timeframes. On top of that, and since we are now talking a lot about a lot of sites, so the run is obviously creating a scale of hundreds of sites with multiple core locations, and that, along with the requirement to deploy many types of application, brings us into the requirement to deliver an automation which allow us to simplify the use cases of the deployment. Going really fast into the evolution and what we are doing in order to transform from cloud ready, which is the traditional virtualization with virtual machines, into the cloud native world, which allow us to deploy over containers. Basically, we see that the form factor is obviously changing from VM to VM plus containers. We see that now we don't only have virtual network function, but we are going into a CNF, into containerized network function, cloud native network functions. In terms of the network virtualization, so we are not no longer talking only about the core and consider physical devices for the edge and the radio. Now, both the core and the edge are virtualized. In terms of the private and on-premise, we are now talking about multi-cloud. So there will be use cases that we need to deploy our application on any type of cloud, including edge and in some cases a public cloud. In terms of the traditional MANO that we used to have with the Vim layers and the NFVI layer and the VNFM and NFVO, now we are speaking about a new type of cloud-first automation that basically need to take us across all the different technology that assemble the cloud. Moving forward, in terms of the operation, we need now to integrate into a CI/CD pipeline that basically allow us to keep the agility in terms of how we deploy application and how we scale the application. In terms of the central side, we spoke about the requirement to scale above 100 sites. So from traditionally of 10 sites at the edge, which most of them are physical, suddenly we have hundreds of virtualized location at the edge, plus tens of virtualized location at the core. In terms of the operational aspect, so instead of having a single OSS that manage the deployment, now we have multi-layer of automation, including the VMware automation that I will speak about it in a second. So going into a mirror of a 4G into 5G, we can see that in the 5G, we are reaching into a world that everything is much more decoupled, much more distributed, spend on multi-technology and multi-site. Suddenly, instead of having a single cloud with a single VM and a single SDDC, we have a remote virtualized sites which assembled from multiple technology. Some of them are open, some of them are based on a VM, some of them are based on the containers, and some of them are even running on a public cloud. The application are much more decoupled. Instead of having one application that's responsible for operational aspects, we suddenly see four different type of application at the edge, and the EPC on the core assembled from six different applications, and everything is much more decoupled. When we are speaking about the automation, we see that instead of having a single automation platform to the cloud, we now need an automation platform plus SDDC automation plus CAS automation and plus the CI/CD integration in order to support the agility of the deployment. In terms of the adoption that we did in VMware, so we did some facelifting into our automation platform, the TCA that we released last year, which was formerly known as Project Maestro, and we did a facelifting in adding the SDDC automation and the CAS automation in order to allow the deployment of the remote site. So now you can see that instead of just managing the traditional stacks with VCD and VIO, we are now managing also Project Pacific and TKG offering from FBU in order to allow the deployment of the remote site along with the CAS layer on top of the traditional SDDC stack that we have. The automation allows us to deploy the SDDC, to perform the zero-touch provisioning for all the SDDC stack along with the CAS stack, and to make sure that the CAS is optimized based on the CNF, the application requirement, and in the end to chain it into a meaningful network service. All of that will come with the policy and placement engine that allow us to make sure that our application and our deployment answer all the criteria as defined by the customers. In terms of the platform itself, so we spoke about the VNF management, the XNF management, and the network service orchestration. A very important part is the placement engine, which basically allow us to keep the policy based on the criteria that the customer set. And next to it, it's the telco APIs, which actually differentiate our platform from the different platforms that we have inside of VMware that dealing with automation, and basically take the TCA into the place that allow us to integrate it into any service provider network that deals with the cellular networks. There is a main difference between how you run automation in the traditional IT networks to how you run automation in the network side of the service provider. And the telco API part of TCA, this is the part that gives us the edge and the capability to integrate into any network. So most of the other components of the TCA will look kind of similar to other automation platform. Still, the telco APIs is actually the extension parts that allow us to maintain the requirement of the service provider and to allow ourselves to integrate with any VNF and CNF that serves networking application, which comes from the NEBs, the network equipment provider, and allow us to make sure that we deploy all the three layers, starting from the virtualization to the CAS and the application and the network service in a way that answer the customer criteria. In my last slide, I just want to emphasize the telco API use case. So the telco APIs are the ones that actually gives us the privilege of taking all the automation around the virtualization layer and plug and play it into the other parts of the network in the service provider. As you can see in the service provider, there are multiple domains that stretch the network across multiple geographical locations. It starts with the virtualized edge, go through transport of optics, switches, and router, and in some cases involvement of physical runs, which managed by Element Manager from the NEBs. The transport is managed by NMS, and at the end of the day, all of that need to encapsulate into an end-to-end slicing manager or service manager that will know how to spend the service across the multi-domain. The TCA abstract the VMware infrastructure and create an ecosystem with all the NEBs and the application provider in order to take both of the application and the infrastructure and abstract it into the rest of the network in order to make it meaningful and to allow the end-to-end service orchestrator to create any service in an agile way and a repeated way. And this is how you build an end-to-end network which can scale into the 5G use cases. With that, I will move on to Akshata to describe more about the processes of how we deploy a 5G application and a 5G network service.
Thanks, Moshe. So I will walk over some of the steps that happens in the 5G multi-layer automation, as well as go over a quick demo of showing how this process actually happens in the product, right? So here, as you see, it's not just the network services or network function automation that's being done. Right from the SDDC layer, right? From scratch, you can build up the SDDC as well as the CAS. CAS can be built using TCA, as well as the various customizations that is required for each of these network functions and network services can be automated end to end, so that you have these network services deployed right in a matter of few minutes, instead of going each of these layer one by one, right? So let me go over to the demo and go into each of these sections and show how it can be done in the product. So Telco Cloud Automation is a platform for deploying network functions, network services, as well as infrastructure. And it can be, this here we are showing a dashboard of various statuses of various elements, right? What are their current status and how does it look overall as a status from TCA perspective. Now you can also see the alarms as well as the cloud status, all the registered clouds that have been registered here. So these clouds, right, it's not just they can exist in a geographical fashion. It can be spaced across various locations, so that when network services are deployed, it can not only be in one location but can be deployed across, right? So let me go over the SDDC automation part. So here you have the servers racked up. So from there you can design your data center completely. You can say how do you want to place your central sites, regional sites, and the edge sites, and say how you want to bring up your entire data center infrastructure, design it and put it in this JSON template and deploy it from here. So you can also design the CAS infrastructure, which I'll go into it in a bit, and so that you can ultimately plan your network function deployment for your end-to-end network services, right? So here we are making sure all these dependencies are automated and they are brought up one by one, right? So once you have deployed these telco, the infrastructure layer, you see that it gets registered to the virtual infrastructure into this telco cloud automation product, so that it can be used for deploying network services. So there are multiple ways of deploying these, registering these various infrastructure. You could either directly register or create completely from here, right? You can register a Kubernetes cluster, which is already deployed, for example, by providing kubeconfig or VMware Cloud on AWS, or a vSphere cluster that you want to register for this TCA automation purposes. You can also specify, let's say, vCloud Director, a tenant that you want to register for deployment purposes. So once you have registered these, or you can also create your own deployment, Kubernetes cluster, the CAS layer, right? As Moshe was saying, you can come here and design your cluster template. So cluster template is more like it's more like a blueprint of the entire CAS layer. You have the master node config, you have your worker node config, how many replicas of this worker node do you need, if you need some labels that needs to be attached, the CAS information, pass information that you want to automate as part of bring up of this cluster. So in general, when you want to deploy this template, you select the specific SDDC that was already either built from this platform or registered, and then you say which template you want to pick, right? Once you have chosen the template, you can say, you can even give some specific information, like let's say you want to choose a specific cluster inside that SDDC, or which folder, which network you want to use for deployment of this Kubernetes cluster. Now let me go to an example wherein already this CAS, a Kubernetes cluster has already been deployed. So here you see you get all the deployed information, right? Various master node IPs as well as worker node information, and you see that it's ready for onboarding of network functions. And the network function, as it's being deployed, you also see various status of how it is getting deployed, right? It could be that there are some dependencies that have been already registered as part of the deployment of network functions. So now that your CAS and infrastructure layers are ready, now you would deploy or prepare your network function catalog, right? There are various network functions that have been already onboarded to the system, but you could also bring in your own Sol 1, Sol 4 compliant packages that you can upload to this TCA, right? Either you can bring your own package or you can design your package from scratch. So let me show you an example of a virtual network function that is being designed. So as part of this, you see that either you can design a virtual network function or a cloud native network function. You provide all the metadata of various who's a provider and what are the operations available, right? It could be that you don't want to allow upgrade on this network function for whatever reason, so that can be specified. And while also you can also have day zero and day one workflows that has been defined for these network functions. So for example, you may want to run certain certain workflows to prepare your cluster before you want to instantiate, or you may want to say add a validate workflow to make sure that your network function has come in properly after it's gotten deployed. So here you are designing a network function itself. So you are adding a virtual link and various VDUs and specifying the image name and the OVF properties and what is the CPU, memory, and storage details. Once you have all the properties and the connection points defined, external connection point, internal connection points, etc., you can also specify if there are any dependencies across these various videos, right? These videos can also either be VMs or it could be Helm charts that you want to deploy as part of the deployment of this network function. So once you create this catalog, you see that a Sol1 package is being created for you, and this using this package you can deploy it across various platforms, various VMware cloud platform. So this package is created in an automated fashion, and here let me go into detail of one of the already onboarded network function. So here you see there are some infrastructure requirements. So we have extended HC Sol1 packages, right? And we have also added some infrastructure requirements, like if you want to have a specific kernel version, or you want to say you want to specify huge pages or custom packages that you want to add, right? So you can specify all these, as well as CAS and PAS layer. You can say that these are the CNIs that I want to have for this network function. So these are the layered bindings that Moshe was saying while in the presentation. So when you deploy this network function, that is when this the CAS and PAS components are node customizations are happening at that point. And then ultimately, once it is being deployed, right? That's when you see that all of them are end-to-end automated. So if you have these workflows like pre-instantiation or post-instantiation, that also gets run as soon as you deploy this network function. So let me go to already deployed network function. There you see you have reconfigured all the parameters. Once you have reconfigured, it also instantiates the Helm, etc., right? So this is an example of such a network function. All right, so I think I have covered most of the phases that we did go through, right? So let me share the presentation, and so that we can add the closing comments.
Thank you, Akshata. So just a quick recap on where we are with the session so far. So we talked about the requirement for 5G, how it's different from the ones that we used to have in 4G. We spoke about the requirement for multi-cloud with multi-technology, and we said that it's very mandatory to have automation on top of the multi-cloud in order to serve all the 4 layers of automation, starting from the SDDC to the CAS, to the application, and to the network service, and most important, to integrate it into the rest of the network equipment requirement. With that, thank you very much for joining.